AAS Theorem. It says that if two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the two triangles are congruent. This picture says everything. Okay, if you look, this angle here and this angle here are congruent to this angle and this angle. This side is the included side between these two angles, and this side over here is the included side between these two angles. It is not guaranteed that BC, we're not given that BC is congruent to EF. We're given that a non-included side, AB, is congruent to DE. So we're going to prove that these two triangles are still congruent even though it's the non-included side that's congruent. So the first thing that I'm going to say is I'm going to invoke a theorem that we just proved. I'm going to invoke the third angles theorem. I'm going to say that I know that if two angles in one triangle are congruent to two angles in another triangle, then the third angles are congruent. So then that means that angle A, in this case, is congruent to angle D. And this follows from third angles theorem. Okay, now after we have that, right, you can look at this picture again now, and if you look here, this angle is congruent to this one, and then this one's congruent to this one. This side now is the included side between these two angles and these two angles. So what you have now is you have a angle side angle situation. And angle side angle does prove the triangles being congruent. So you have triangle ABC is indeed congruent to triangle DEF. And that follows from angle side angle postulate.